Hello, I'm Tony Williams and I'm here at the International Brotherhood of Electrical Workers at San Diego. They've got a whole lot of solar panels up on the roof here and two nice AeroVironment VSEs to charge my Nissan Leaf. This car here was recently involved in a test that we conducted in Phoenix, and the results of that test were to demonstrate that the Nissan Leaf is not doing so well, mostly in hot environments, and that the range of the vehicle is degrading in a relatively short amount of time. Earlier this month, Nissan's Executive Vice President Andy Palmer mentioned to an Australian news agency that the Nissan Leaf didn't have any problems with its battery and that there was an instrument problem with the car. And this was a result of complaints that the car was not doing the range that it was designed to do, and that the range was decreasing. And so I and a bunch of owners from Phoenix decided to get together and take 12 cars and test them with a real somewhat simple test, but will become a lot more complicated. And that was to have in standard conditions as close as we could get. That meant all the tire pressures were set to 36 pounds. All the tires were the stock Ecopia 422 Bridgestone tire that the car came with. And things like, of course, if it's running at the same time, the temperature will be the same, density, altitude, air pressure density, and wind would all be considered. We selected a course that went outbound to the west and then turned around and came back to the east. So it was an equal distance. So any tailwind it would have had going west, and the wind that morning was slightly out of the east, would be countered by the headwind it would experience coming back to the east. So we would average out the wind effects. And we, for the most part, started and ended near where we, at the same spot. So the test was conducted on Saturday morning. I started very early. I ran my car first at about 3:10 a.m. And the conditions remained mostly the same through about 9 a.m. when we concluded our testing. And for each car, the most that any of the cars drove was 79.6 miles, and that was what I wanted to consider a control car. We had calculated that the cars would go 84 miles, and in fact Nissan's technical bulletin indicates that it can go 84 miles. It also says it'll go 76 miles at 4 miles per kilowatt hour. And 4 miles per kilowatt hour will give us the 100 kilometers per hour, or about 62 miles an hour we set as our target speed. So we loaded up our stuff and we went to Phoenix. I had to trailer this car, and we went about 400 miles, almost 400 miles from San Diego to Tempe, Arizona, near Phoenix, to begin the test. I left here at around noon. I got into Tempe around 7 o'clock in the evening, 7 p.m. And that was on Friday, the 14th of September. Once I arrived, folks already had cars arriving at the staging site, and the cars were beginning to be charged. We had on site one DC charger and two L2 chargers. The battery itself consists of 48 modules. Each module has 4 cells in each module. 2 of the cells are wired in parallel, 2 in series. Each one will power up to 4.1 volts per cell at 100%, or 4.05 volts at 80%. And it'll allow each cell to go down to about 3 volts per cell on the lithium manganese cells. 4 cells per module makes up for 192 cells, so 96 cell pairs, and it's the 96 cell pairs that are actually monitored for voltage in the car. Of those cell pairs, they allow a 50 millivolt variation between a full charge, 393.5 volts total, so 4.1 times 96 cell pairs, 393.5 at a full 100% charge. There is a certain amount, obviously, that's normal. Every battery is going to lose power over time. But the problem we have here is when you compare a car that's been in service for a year, or slightly less than a year, or slightly more than a year. In the case of this car, 3.5 months that it's been since this car was put in service. And of that 3.5 months, almost a month of it sat doing nothing. The car already has lost 10% of its power. I drove this car in June, so the car was literally 2 weeks in service. It was built in April of 2012 in Japan. It was shipped to the United States. It went to a high volume dealer here in downtown San Diego, and Mossy Nissan. I bought the car as a lease. I sold my previous car because it had a 15%, actually a little bit more, reduction in range. And it wouldn't do the trip I wanted to do from Mexico to Canada. So I decided to get this one. The payment went way down. I was happy with that. I liked the car in general. What was difficult in our planning was because the column counting was somewhat pessimistic, the cars went further than we estimated. So cars that we thought would go, let's say, 65 or 70% were going 68 and 73%. So the recovery process just became more difficult because we couldn't estimate as accurately as I had hoped. My car was very, very close. I was able to estimate that it would go 74 miles based on the Coulomb counting device that we had, the so-called GID meter, and I went 76.6, and about 6/10 of a mile of that was rolling to go to a stop because I was on a bridge doing a turn and I didn't want to get off there, so I held the accelerator all the way to the floor. The top speed in turtle mode might be 25 or maybe 30 miles an hour in that particular scenario, and it'll go about a half a mile. So I got it off the bridge, got well off the highway, and then the car went to cutoff. I would recommend that Nissan would do a few things first. One is to make the customers, who are those early adopters, who by a California study that was done here by the California Center for Sustainable Energy, that's the folks that handle rebate checks for electric cars for the state, and it's a nonprofit. They did a study, and it turns out that over 50% of the owners of the Leaf in California, by their study, have a graduate level degree. General Motors, when there was a problem with the Volt, and I'm not convinced there even was a problem, but it made the news, people stopped buying the car. General Motors responded by saying, if you don't like the Volt, bring it back and we'll give you another car. And Nissan could do that right away. Now they're going to get more than 8 people that I heard, 8 or 9 people that actually exchanged their Volt. They might get hundreds. But it's the right first step, I think. Offer them another Nissan car. Other manufacturers do stuff like that all the time. I'm sure Nissan has done stuff like that all the time. And of course, they've had issues with other cars. The constant velocity transmission on one of their model cars was and maybe is still a big problem. I'm not sure. I don't really keep up on automotive news like that, to be honest. But other things they can do, of course, offer maybe employee pricing or a big discount. It could be a $5,000 discount coupon on the 2013 or 2014 Leaf. So they can just wait it out. They'll be happy as a clam knowing they're going to get the latest technology. It may or may not have different battery technology. Carlos Ghosn, the chairman of Renault Nissan, has announced kind of in a, the same way that Andy Palmer announced something. I think it was an interview, maybe an off-the-cuff remark, and it's made news. But his statement was that the 2013 Nissan Leaf would have a new technology battery that would have more energy, more stored energy, and be lighter and cheaper, and all the good things that we anticipate and expect in the future in automotive batteries. So if they gave them a discount coupon, I'll bet the folks that are chomping at the bit to get Nissan, and to be honest, there's very few of those, most of them have more than been accommodating to help Nissan in any way. When they've asked cars to come in to be tested, folks do it, and most people who are electric vehicle advocates want to see both this car succeed and the greater electric vehicle community at large succeed. For Nissan to really botch this bad will not be good for everybody else. They have to get this right, and they have to kind of wake up that there's going to be. They should have known that there was going to be some issues and set aside some money and some folks and resources to handle what things would pop up, especially a new car with new technology into a new market. And why they're not doing that, to be honest, I don't know what's in it for them. Subsequent to us doing this testing, they've announced that in the next few days, so it could be sometime before next week, let's say, in the next few days they should have a an answer. Now what that answer will be, you know, they can play it any way, to be honest. They can keep with the everything's normal, and in which case I predict that the owners are going to make sure that the world knows that 30% loss in range is normal. Don't buy this car. It would be a dumb, dumb, dumb move. They've already kind of delayed the inevitable, which is they're going to have to do something, and I do hope that they do turn the ship around, and I do hope that that we've in the most honest manner that we could indicated to the leadership of Nissan that these cars are kind of in trouble. Granted, you might be able to snowball the whole world and sell them a car in a place like Seattle or San Francisco that had exceptionally cool weather this year, and that car might go a long, long time before it'll exhibit a problem just because of the lower temperatures. So folks in San Francisco, Seattle, Portland, and England, where there's a number of cars, don't get worried about the battery for any short-term time. If you're only keeping the car a few years, 2 or 3 year lease, or you're going to own it for 2 or 3 or 4 years, you're probably going to have a fairly normal amount of degradation, would be my guess. Of course, I can't bet on that. But in places where it's hot, and in the U.S., the middle of the U.S. really baked this year. Oklahoma, Texas, of course Arizona, some of them had record temperatures all year. And in addition, these cars that are sitting on a black asphalt parking lot, that sun is just absolutely baking and heating up that asphalt. 140, 150 degrees is certainly normal to be measured. And the interiors of the car can hit 150 to 180 degrees. The very interior that the battery is bolted to on the bottom of the car. The worst car that came in at 59.3 miles, we did the test on that Saturday morning, the 15th of September, specifically because he was to turn in his car to Nissan on that afternoon. And he did. We went and had a breakfast after our event, and he drove the car straight to the dealership and turned it in. Now, Nissan charged him $693 for the privilege of turning in his car early, which in itself is a pretty good program. It has nothing to do with there's a problem with the car. As a matter of fact, they made absolutely no concession or even admit that there's just anything but everything is normal, even though the car drives 30% less than it did when new. But subsequent, now this is after our event and after I published the results on the internet and after it's been emailed and forwarded around the world a few times, Nissan did actually come back to that owner and refund his $693. And I would like to think, maybe we've turned the tide around just a little bit, because so far the executives publicly at Nissan who are responsible for this electric vehicle program have been anything but accommodating when it comes to mentioning there's a problem with the car. And that's very unfortunate when you're talking about something as critical and fatal to the entire electric car industry as having a major manufacturer pumping out a car where the battery degrades so quickly, within a year 30% less range, and the answer is we're not going to do anything. It's not our problem, it's all normal. And by the way, they'll also tell you they don't warranty range, so even if it wasn't normal, it doesn't matter anyway. Or actually, I take that back. They don't warranty battery capacity. They actually don't say anything about range, so you can make of that what you will. This is one of those cases where I think it would be wise to do right by the consumer, and that consumer, I think, by an overwhelming margin, will stop doing whatever it is they might be thinking of doing or currently doing in terms of complaints, public airing out issues, going to legal places like the Attorney General, the federal regulators for vehicles, and of course lawsuits, lawyers, and the rest of it. That's how they can fix it. They don't have to fix the battery issue or whatever issue may be in the car. They need to first make the customer whole, then figure out the problem and make it right for both the cars in the future and the cars in the past. And with that, I'm going to say thank you, everybody. I'm glad you listened, and it's back to you, Jack.